On October 19, 2017, astronomers at the Pan-STARRS 1 telescope in Hawaii detected a faint, fast-moving point of light, unlike anything seen before. This object was on a hyperbolic trajectory, moving so fast that the sun's gravity couldn't capture it. It was the first confirmed interstellar object ever observed by humanity. The discovery electrified astronomers worldwide. Here was a visitor from another star system, right on our doorstep. Telescopes everywhere scrambled to gather data before it slipped away forever. Officially named 1I/2017 U1, it was also given a more poetic name, Oumuamua, meaning a messenger from afar arriving first in Hawaiian. Oumuamua was already heading away from the sun when discovered, fading rapidly, and giving scientists only weeks to study it. Every observation was precious, a fleeting chance to learn about a true interstellar traveler. What they found was both fascinating and deeply puzzling. Oumuamua didn't fit any known category of asteroid or comet. Its properties challenged our understanding and sparked debates that continue to this day. The universe had sent us a mystery, and we had only a brief moment to try to solve it. Oumuamua's path through our solar system was our first clue to its alien origin. Unlike local objects, which orbit the sun, Oumuamua's hyperbolic trajectory meant it was just passing through, never to return. It entered from the direction of Vega, traveling nearly 59,000 miles per hour, and looped tightly around the sun, reaching speeds of 196,000 miles per hour at its closest approach. 5 days before discovery, it crossed Earth's orbit, already on its way out. By tracing its path, astronomers confirmed it hadn't come from our solar system, not even the distant Oort cloud. This was the first direct proof that interstellar objects wander the galaxy, and sometimes visit us. Its journey highlighted the dynamic, interconnected nature of the cosmos. As it receded, Oumuamua became a cosmic ship vanishing over the horizon, a rare event we were lucky to witness. The data from its brief visit opened a new window into the building blocks of other planetary systems. We caught a fleeting glimpse of a true interstellar wanderer. What truly set Oumuamua apart were its bizarre physical properties. Its brightness varied by a factor of 10 every 8 hours, suggesting an extremely elongated shape, perhaps 10 times longer than it was wide. This cosmic cigar or needle shape is rare for natural objects, which are usually more rounded. Spectroscopy showed a reddish hue, hinting at long exposure to cosmic rays, consistent with a long interstellar journey. Despite passing close to the sun, Oumuamua showed no signs of a coma or tail, unlike any comet. It appeared inert, like an asteroid, yet its movement was even stranger. As it moved away from the sun, it accelerated slightly, something gravity alone couldn't explain. For comets, this is usually caused by jets of gas, but Oumuamua had no visible outgassing. Its combination of shape, lack of a tail, and mysterious acceleration made it a true cosmic outlier. It didn't fit any established category, forcing scientists to consider new, even exotic explanations. Oumuamua was a puzzle from across the galaxy, with pieces that didn't seem to fit. Oumuamua's anomalies ignited a fierce scientific debate. Was it a natural phenomenon or something more? Harvard's Avi Loeb famously suggested it could be alien technology, a light sail propelled by starlight, explaining its acceleration without outgassing. Perhaps it was a defunct probe or buoy from another civilization. Most astronomers, however, argued for natural explanations, insisting extraordinary claims require extraordinary evidence. They developed new models to explain its shape, lack of coma, and acceleration, seeking a single, coherent natural theory. Hypotheses ranged from hydrogen or nitrogen icebergs to unusual comets with invisible outgassing. Each idea was scrutinized and debated, exemplifying the scientific method in action. The debate wasn't just about Oumuamua. It was about the limits of scientific evidence and imagination. While the alien probe idea captured headlines, the scientific process demanded rigorous skepticism. The mystery pushed science to its limits, but demanded careful, evidence-based inquiry. When faced with a mystery like Oumuamua, imagination is vital, but so is skepticism. The alien artifact hypothesis is intriguing, but the evidence simply isn't there. Science is full of once inexplicable phenomena, later explained by natural processes. Oumuamua likely represents a new class of natural object, formed under conditions unlike anything in our solar system. Its non-gravitational acceleration could be due to invisible outgassing, perhaps from hydrogen, nitrogen, or carbon monoxide. A nitrogen iceberg, chipped from a Pluto-like exoplanet, could explain the push without a visible coma. Before jumping to aliens, we must exhaust all plausible natural scenarios. Scientific humility means demanding extraordinary evidence for extraordinary claims. The most responsible conclusion is that Oumuamua was a fascinating natural object that expanded our understanding of the cosmos. It's a puzzle that points to new astrophysics, not necessarily to extraterrestrial technology. Scientists have proposed several natural explanations for Oumuamua's oddities. One theory suggests it was a hydrogen iceberg, formed in the coldest regions of space, sublimating near the sun and providing invisible thrust. Another, more robust theory posits a nitrogen iceberg, a fragment from a Pluto-like exoplanet, with nitrogen outgassing explaining the acceleration and lack of a tail. Some suggest it was a highly unusual comet, with outgassing of nearly pure gases that produced no visible dust. Our definition of comets may be too narrow to encompass the diversity of interstellar objects. Another idea, a cosmic dust bunny, a porous, low-density clump of dust and ice, easily pushed by sunlight or minimal outgassing. Each theory relies on known physics and chemistry, offering scientific alternatives to sensational claims. These ideas push the boundaries of planetary science and expand our view of what's possible in the galaxy. Oumuamua challenges us to rethink our assumptions about the universe. The search for answers continues, grounded in evidence and creativity. In August 2019, astronomers discovered 2I/Borisov, the second confirmed interstellar object. This time, scientists were ready, tracking Borisov for months as it approached the sun. Borisov behaved like a classic comet. It developed a bright coma and tail, and its composition matched comets from our own solar system. The only extraordinary thing about Borisov was its origin. It came from another star. Borisov's normalcy highlighted just how strange Oumuamua was. If Borisov is typical, Oumuamua is a true outlier. Some argued Borisov's existence proved interstellar visitors are natural, while others said it made Oumuamua's weirdness even more significant. With only 2 examples, it's impossible to draw broad conclusions. The contrast between the 2 objects sharpened the debate and underscored the need for more data. We've only just begun to sample the diversity of interstellar visitors. The universe has more surprises in store. In today's media landscape, sensational headlines often outpace scientific facts. The idea of Oumuamua as an alien probe captured imaginations, but it's crucial to separate speculation from evidence. As of now, claims about Oumuamua reappearing or being accompanied by others are unfounded. Sensationalism can erode public trust in science and distort the real process of discovery. The scientific debate about Oumuamua is healthy, but it's often misrepresented as proof of alien contact. Scientists and communicators must be clear about what's known, unknown, and speculative. Avi Loeb's hypothesis is part of the conversation, but it's a minority view not supported by most evidence. The real excitement lies in the genuine mystery and the disciplined search for answers. The universe is mysterious enough, no embellishment required. Though Oumuamua has vanished, its legacy endures. Its discovery proved that interstellar space is filled with wandering objects, sparking a new era in astronomy. New telescopes like the Vera C. Rubin Observatory will soon scan the sky for more interstellar visitors, transforming isolated discoveries into a robust sample. We'll learn about their shapes, compositions, and origins, piecing together a galactic story of planetary formation. Oumuamua inspired bold mission concepts, rapid response spacecraft ready to intercept future visitors. Imagine sending a probe to study an interstellar object up close, a monumental leap for science. The technical challenges are immense, but the potential discoveries are even greater. Oumuamua challenged our definitions and sparked debates about evidence and imagination. It reminded us that profound mysteries still await in our cosmic backyard. The journey of discovery continues, and thanks to Oumuamua, we're better prepared for whatever the universe sends next.